The fifth is resistance. Resistance is the property of material by which it opposes the flow of current through it. 1 ohm of resistance exists if there is 1 ampere of current in a material when 1 volt is applied across the material. You can see from this picture to get a clear what it means by it opposes the flow of current through it. Okay. The symbol for resistance is R and the unit is ohm. This is the schematic symbol for resistance. Resistance related to resistivity. So before we go into what is resistivity, we look into property of materials. Basically, there are 3 types of materials that exist around us. The first one is conductor, a material that allows electric current to flow easily. The example is copper and iron. Second one, insulator, a material that does not allow or prevent the electrical current flow in normal condition. It has a lot of valence electrons, but the valence electrons are difficult to be free from its parent atom. For example, rubber, glass, and air. That means insulator, it won't conduct electricity. The third one is semiconductor, a material that has a conductance value between conductor and insulator. It has 4 valence electrons and can be used to make electronic components. For example, silicon and germanium. So in our electrical circuit, we more focus on conductor and insulator. Resistivity is the characteristic of conductive material to opposition or decrease the current flows in it. The symbol is rho and the unit is ohmmeter. Okay, it's the characteristic of conductive material. Next, we look into factors that affect the resistance of conductor materials. The resistance of given material depends on the physical properties of the material. There are 4 factors that influence the value of resistance. First, length of conductor, L. The length of conductor is proportional to the resistance. For example, the longer the length of the wire, the higher the resistance value. Second, surface area, A. Area is inverse proportionally to the resistance. As the resistance increases, the cross-section area of a conductor will decrease. As you can see here, are inversely proportional 1 to A. Third, resistivity. Resistivity is proportional to the resistance. Higher the resistance, higher the resistivity. R directly proportional to rho. Rho is the symbol of resistivity. Fourth, conductor temperature, T. The conductor temperature is proportional to the resistance. As the conductor temperature increases, the value of resistance also increases. R proportionally to T. Okay, here is the resistance of a conductor. This is one conductor, the area, the length, will affect the resistance value of this material. Mathematically, formula for the resistance of a wire of length L and the cross-section area A is as equation R equal to rho times L divided by A, whereas A, a cross-section area, units meter square, rho resistivity ohmmeter, L the length unit in meter, R resistance unit is ohm. Any questions so far? So let's recap. There are four factors that affect the resistance of conductor materials, which are material, the resistivity, the length of the conductor, the cross-sectional area, and the temperature. These four factors interrelated. Now, let's see some example how to calculate the resistance of a conductor material. Let's see the relationship between resistance, length, cross-sectional area, and resistivity. Let's do this example together. Calculate the resistance of a 1.5 km length of aluminium wire. Given diameter wire 10 mm and the resistivity of aluminium is 0.025 microohmmeter. Okay, the solution is we have been given D, the diameter, equal to 10 times 10 to the power of minus 3. Why power of minus 3? Because it is millimeter. We must convert it to meter. The length is 1.5 kilometer. So we must convert it to meter. So the length is 1.5 times 10 to the power of 3. And the resistivity rho is 0.025 microohmmeter. So micro equal to 10 to the power of minus 6. So by using the equation R equal to rho times L divided by A. As you can see, we have the rho value, we have the length value, but we don't have the area value. We have given the diameter, but we don't have the area. So how to get the area? Anyone get the idea how to get the area? The cross-sectional area. Okay, let's solve this example together. Still remember formula area for a circle? A equal to pi r squared. Okay, as we know, aluminium conductor, the cross-sectional area is a circle. So, area for the aluminium wire, A equal to pi r squared. So, we have given the diameter. So, to get the r, we divide the diameter by 2. So, substitute the value, pi times 10 times 10 to the power of minus 3 divided by 2 and power of 2. Now use your calculator and you will get the area for the aluminium is 78.54 times 10 to the power of minus 6 meter square. Everyone got this answer? Now we get the area. So by using this formula, R equal to rho times L divided by A. So we substitute the value. The rho is 0.025 times 10 to the power of minus 6 times 1.5 times 10 to the power of 3 divided by 78.54 times 10 to the power of minus 6 equal to 0.477 ohm. So the resistance for this aluminium wire is 0.477 ohm.